Hi guys, so I'm going to go through the choose probability method here. This can sometimes be very handy for working out probabilities. It's not always the best method, but it definitely comes into its own when you are talking about choosing especially cards out of a pack. Now, before we get into this, I suppose it's a good thing to revise what choosing is. Choosing is when, for instance, you're picking a team. Let's say you have a panel of 15 and you are choosing 5 players from that. So you'd write that as 15 choose 5. And you put that into your calculator, you are going to get 3,003 different ways. Now, the order obviously of a team doesn't make any difference. If I choose player A, player B, and player C, I can choose player C first, player B second, player A third. It's still the same team. So the big thing with choose is that it doesn't take, the order doesn't matter. If we simplify things down to, because it's hard to get your head around numbers that size. So let's suppose that we have 3 players, okay, and we have players A, player B, and player C. And instead of 15, this is our panel here of 3 players, and I'm to choose a team of 2. Well, that you can list out. So the only way of choosing teams from that would be player A and player B, player A and player C, or player B and player C. Right, so they're really the only combinations that you can have with 2 players in that. Now, we'll see that if you put in 3 choose 2 into your calculator, which is what I'm doing there, you're going to get the answer of 3. So that, on a small level, a small scale, it's easier to get our heads around. When it gets up to really large numbers like these, it's very hard to get your head around the fact that there are 3,003 different ways to choose a team of 5 from a panel of 15. Now, at this stage as well, I suppose I want to make sure that you are clear on the differences between choose and permutations. So let's stick with this example here and let's talk about, well, what if I was talking about permutations here? So how that would be phrased is how many ways can you arrange two players from 3, and that is written as 3p2. So again, let's go through what the actual arrangements of those are. So we could have player A with player B, but we could also have player B with player A. So you see the order there gives you 2 different arrangements. They're not different combinations, but they're different arrangements. So that is where heads usually get wrecked with this. And it's good to come back to this because I know we've covered it, but it can all too easily fall out of your memory. Okay, so player A, player C, again, player C and player A, and then player B and player C, and then player C and player B. So you can see there are 6 different arrangements when you are choosing 2 players from 3. And the reason for that is that the order matches. So out of a matter of interest, just go to your calculator and check that 3p2 is equal to 6. Interestingly enough, when you go and do 15p5, you get a really, really big number, hundreds of thousands for that one here, once you have order into it. So choosing the order doesn't matter, okay? A, B is treated as the same as BA. So there isn't, it doesn't get 2 choices. Whereas with permutations, AB is a different permutation to BA. So be careful. Now, generally we don't use permutations for leaving cert for calculation of probability. Now, you can, but it's a bit messy. So I'm just going to go through the choose method here. So let's look at a question then. So if we have 3 cards, they're chosen from a full pack of cards, what's the probability that all 3 cards are queens? So let's look at this from what I suppose would call a general probability method. So the method that I would have shown you. There are 4 queens in a pack. So your first choice, your probability of getting a queen is 4 out of 52. Now, the second choice, there are no longer 4, there are only 3 queens left, and there are no longer 52 cards in the pack, there are 51. So that's your probability of picking a queen out in the second choice or pick. The third one follows the same pattern. There are now 2 queens left, and there are 50 cards left in the pack. So when you multiply all of those together, you get a very, very small number, 1 over 5,525. Now, that's fairly straightforward. When we go to the choose method, now what we are doing with the choose method is you are looking at the number of outcomes that you want, okay, over the number of possible outcomes here. So what are the outcomes that I want? Well, I want a queen. I have 4 queens and I'm choosing 3 from there. So the number of ways that I'm going to choose the queen goes on top. And that will give me the total number of ways that I can basically pick out 3 queens out of the 4. Out of the whole pack, I have 52 choose 3 ways of picking 3 cards from the whole pack. Now, that's the total number of possible outcomes. On top is the number of outcomes that I want. When you run the numbers on that, you get 4 over 22,100, and that simplifies down to the same as what we had above, 5,525. So I'm going to get the same answer both times. I'm just doing it a different method. Now, again, for that example, there is nothing to be gained from using the choose method. But the next example that I'm going to show you, it is significantly easier if you use the choose method. Okay, so back to choosing 3 cards from a full pack. What's the probability that only 2 cards are red? Now, if I have 2 cards that are red, I have the following possibilities. I can have red, red, and black. I can have red, black, and red, or I can have black, red, and red. So what I'm going to have to do is I'm going to have to work out the probability of each one of those and add them together, which again isn't the end of the world, but is a bit long and a bit tedious when you are putting it into your calculator. So let's start with this. If I have basically 26 out of, actually, I'll start this over here. So the first one here, if I put red, red, and black. So the probability of getting a red as my first card is going to be 26 out of 52. So 52 cards there. Times the probability of getting a red on my second card. Now, I had 26 reds to start with. I chose 1, so I now have 25 reds left. 52 cards to start with. Choose 1, you've got 51 cards left. And then my third card being black. Now, I haven't chosen any black, so there are still 26 black cards left, but there are only 50 cards in the deck. So that bottom number is always going to go down by 1 each time. But what you need to be careful of here is the top number. I'm choosing a red here, then another red, so from 26 reds to 25 reds that are left, but then I'm going to choose a black for the second one. So work out that and add it to my second possibility, which is red, black, red. Now, again, starting off here, 26 reds out of 52. Black cards, well, I still have 26 cards out of 51 black. And then red cards, I have 25 here out of 50 that's left. Now, you can see that you need to watch your fractions here. The third one, black, red, and red. Okay, 26 black cards out of 52 at the very beginning. Reds, then I have 26 out of 51 remaining, and then 25 reds out of 50 remaining. So once I multiply all of those together, and that's quite a fraction, I end up with 13 over 34, which is my answer there. Okay, now the choose method. Well, what am I doing here? I am choosing, remember the question here, I want two cards that are red, so obviously the other one has to be black. So I'm choosing two red cards out of 26. So I have 26, choose two, and I want to choose one black card from 26 black cards. So remember what I was saying about the word and. When I use and, I'm multiplying. So 26, choose one. Now note I don't have to do anything about order here. It's the number of choices that I'm picking a red card and the number of choices that I'm picking a black card. So 2 red cards from 26 red cards, 1 black card from 26 red cards. And that's all over picking from 52 cards a total of 3 cards. So this is the total number of outcomes that I have here. That turns out to be 325 times 26. Okay. 26 choose 1 is 26, and 52 choose 3 is 22,100. That simplifies to, well, 8,450 over 22,100, and that simplifies to 13 over 34, which is exactly what we get up here. So much simpler calculation here versus having to do the orders up here. Now imagine that you had a situation where you had 5 cards that you were choosing here, and you were, for instance, a full house in poker, 2 of one suit and 3 of another suit. If you had to go through all the different possibilities here, you might have anything up to 10 or 15 different ones that you have to add together. Now that's a very difficult calculation to do, very time consuming, and that's where your choosing method really comes into its own. Okay, I'm just going to give you 1 or 2 questions that use this in the book. So in your book on page 82, question 16, they're talking about a poker hand is dealt randomly. That can be done using the choose method, and question 19 on the same page also can be done using the choose method. Now you'll notice that those 2 examples are to do with choosing cards from a deck of cards, and that is where the choose method really comes into its own. The other example that I gave you question 10 for homework tonight on page 85. That's another one that can be done with using the choose method. So those are 3 questions that would be really good for you to go now, having seen this, practice. You have the answers for 16 and 19 anyway. They're on the Google Classroom. Try it with the choose method and see, do you come up with the same answer. Okay, thanks guys.